Bang on 11:30. Let's make a start. Thank you to all of our supporters, all of these companies that helped make last conference a success, all of the session leaders and the other volunteers who give up their time to make last conference not only as enjoyable but also as affordable. And without these supporters, we certainly wouldn't be able to have a successful conference that we'd know and love today. So thank you to our supporters. Jack and the Beanstalk, hands up if you're in a team or know a team that does CI. Pretty much all of us. That's excellent. That's fantastic. So we're already off to a great start. What problem are we trying to solve? Well, we want code always releasable, and we're focusing initially on that build step and making sure our code is always building and creating a release. So that's the first problem. That's really what we're trying to solve with continuous integration. Now, the reason for this presentation, I was in a conversation with a number of my development teams and had a few challenging conversations where things didn't quite match up, and we had very different opinions and understandings about what this was. ThoughtWorks have a radar where they start promoting and telling people about new wonderful technology that we should all adopt and microservices and all this cloud infrastructure. And they tell us stuff that maybe hold back at this a little bit, and things that we should definitely avoid. And in March 2017, a new thing popped up there, number 21, was CI Theatre. CI Theatre, well, most developers falsely assume they are doing CI, and this doesn't make any sense at all to most of my teams. When I've gone in, I've ticked the tick box. What do you mean I'm not doing CI? And this is where we end up in a situation where the English language is a wonderful thing, but it's always easy to misunderstand and have different opinions. I've enabled the capability to do continuous integration, but just ticking the tick box is not enough. That's just all show and theatre. Let's pull back the curtain and start the show, because this is the reference to Jack and the Beanstalk. I don't know how many of you have been to England or remember a pantomime when you were young. But it's all show and theatre. Let's start talking about the real. What do we really mean by continuous integration and the branching strategies around continuous integration? So let's start the show. Hands up if you've read the book on the left. Hands up if you've read the book on the right. All right. Of the two, recommend the book on the right. Not only is it a little bit more recent, but it has a huge chapter on continuous integration, and then talks about the rest of the delivery lifecycle. If you only read one book, read that, get the continuous delivery. Continuous integration, much older. Some of the technology it describes in there is obviously older, but the principles still apply. But if you haven't read either of those books, get the one on the right-hand side. It will make a huge difference to your career if you can apply those principles in Jez Humble's book, Continuous Delivery. It's $30, and it will add a lot more than $30 onto your career. You'll get employment anywhere in the world if you can apply those principles in continuous delivery. And this is potentially the start of where I was getting some challenges about continuous integration and trying to apply continuous integration, and everyone had a different understanding. So does anyone have a word or a phrase that means continuous? What do we mean by the word continuous?
Ongoing.
Ongoing, yes, great. Another one?
No break.
No break?
Always.
Always, yes, constant. I like to think of dripping taps when I think of continuous. The one on the left, continuous flow of water. No doubt about that, that's continuous flowing. The one on the right, that's a drop. And then you have to wait, and there's another drop. Maybe it's regular, it's definitely not continuous. And so always I like to think of that, the tap, continuous flow of water, never ending. What do we mean by integration? So clearly that's a much easier thing. It's all the stuff that we get code, developers, features, components to a product. That's integration. All of that stuff has to be integrated into our product, and it has to work together. That's what we mean by integration. So what do we mean by continuous integration? It means constantly, never ending, always continuously, don't stop, always do this integration. If at any point there's a gap or a delay, we no longer have a releasable product, particularly if component X has a dependency on component Y. So we're looking at a continuously integrating this stuff. Okay, so the definition. So we'll jump straight into the official definition, obviously Wikipedia, but it's the same definition that we'll find comes out of Jez Humble's books and all the other books and blogs about continuous integration, mention the same patterns. It's all developers on the team merging into a shared mainline or master multiple or several times a day. Now this is hard, but this really is the definition of continuous integration. And it's hard, and lots of teams have just ticking the tick box. I've set up a build server, builds overnight. I'm using Jenkins as there's another toggle in here, and we call it CI, but it enables CI. We're not doing it unless we do these activities. And this is only the first part of what really continuous integration means. When you read the books or you read the blogs behind what this means, they talk about more things to become continuous integration or to perform continuous integration. The first thing, if we're going to CI theater, we're not quite there yet. We're actually checking into or committing into a repository, but they're actually on separate branches. They're not really integrated. We need them onto the same shared mainline or master in order for them to be really integrated. And we're not really doing continuous integration if it's only a couple of people some of the time. We need the whole team. Every developer commits at least daily into the shared mainline. That's part one. Now, Martin Fowler has written a post underneath here about getting continuous integration certification, and he mentions there's a second stage here. Every commit has to trigger this automated build and test, and not just your unit tests, but they have to be integration tests to make sure that those things work together. Look at my class, my unit works by itself. Great, fantastic, but when you integrate it, does it work integrated together with all the other components? You need one level up from unit testing to make sure that the components work together. And it's no good if you only have here a partial low level of coverage. It's not integrated unless it works integrated. Like, oh, my build works, it compiles, yeah, but it doesn't matter if it doesn't work. We have to have high coverage, high code coverage, high integration test coverage to really do continuous integration. It has to work integrated and not wait until a tester finds it. All right. The third stage of really doing continuous integration is recognizing when a build goes red, it doesn't stay red. If you're really doing continuous integration and continuously checking in code and it's always running, you fix it within 15 minutes and it goes back to green. If you're doing all of these things, congratulations, you're doing continuous integration. Martin Fowler will give you a certificate. I'm joking, but sure.
Isn't by setting a mantra of saying it must be several times a day daily? This is because continuous integration is a reaction to late integration.
That's a really good question, and I'm not sure that I'll be able to answer that right now. But it is certainly a challenge. The longer you leave it, the worse it gets. And I know a lot of teams still have patterns where it's days before we even integrate, even before we commit, to even know if it's going to build and compile with other stuff. This will be potentially, this is the ideal that we are striving towards. And maybe there's a spectrum from bits of continuous integration and full. If you're doing this, there'd be no argument. This is continuous integration, right? If you're doing that. And maybe we're not quite there. We're close. We don't, 10 minutes? Hey, we'll do it in an hour, right? The build will get repaired in an hour. That's a great target for us, right? But this could be the goal that I want to strive towards and actually get a lot more efficient. But good question. When this is really tough. But when Martin Fowler, Jez Humble, when they talk about continuous integration, this is the goal that we're trying to get to. And being able to do this means you can then feed onto the next cycle of continuous delivery, and deployment where you're able to deploy multiple times per day. I come up with an idea in the morning, I've tested it in production by the afternoon. That's really, really hard. Right? But it is possible, and it's possible in any industry, regulated industry with legacy applications. Martin Fowler and Jess Humble have proven it. There's the DevOps Handbook, a number of case studies in there. This is possible, but it is hard. And it's very hard if you've got different people with different opinions about what CI is. So the first thing is, we understand this is clear, but it's hard. How do we get here?
Yeah, and it's a beautiful scenario, but look, as you said, it is hard. And then there is a large effort to get to that point. So is there a way to measure how much effort should I put it, and what is the ideal scenario if it's not every day, every time? To my company or my project, what is the right balance? Is there a way to measure that, or should we keep pursuing that regardless of the effort?
I'd love to have that conversation with your team. This is very similar to the conversations I've had with my teams. Like doing this, we're not here. We're doing this theatre. We're calling it CI because it builds overnight. That's not really enough if we're actually on separate branches. Not everyone's doing it, and it's not doing it all the time. But we want to get better. Can we be better? Yes. Is it worth trying to fix up some time to make it better? Yes. But are we going to get here? No, this is going to take us a long time to get anywhere near that. But if there's a way you can evaluate, is it going to be better? Run an experiment. We're going to try one sprint. We're going to try a different technique. Let's see whether we can change the way we do pair programming. Maybe we'll change the way that we time when we do the check-in. So there's always someone back to help fix or come in to help when there are issues and it doesn't work. Maybe there's other things we can do to help understand, is it worth it? Have we got the right balance already? This is as good as it gets.
If we think in terms of outcomes, this enables proper merciless refactoring, proper collective code ownership. So the more stilted and punctuated it is, the less proper those things are.
Maybe we need to have a wider conversation with the other teams. If you're in a large organization and my component works, but that's the slide from 4 slides back, there's this whole other team building component Y. They're happily in their own merry land building component Y in their own merry way, but it's not going to help if we have a dependency on them and they're holding us back and blocking us. So look, maybe they need wider conversations to see, well, what's right for us or what's right for us now, and can we make that a bit better? But this is the CI pattern that we want to aim towards, and this feeds into all of the other continuous delivery, continuous deployment patterns that top performing companies are doing. So let's figure out a bit more about the how, and now into our branching in our Jack and the Beanstalk story. This is hard, but we want to try and get this automated build and test. How can we get that? How can we do that? So there's a number of different patterns. I'm going to go through 3 of these patterns, and maybe you can share your ideas and experience with other patterns that you've used, and ones that work or ones that don't work. Trunk-based development, where we are directly committing to trunk. Clearly, this kind of falls into that desire about continuous integration, where if every developer is checking into this master multiple times a day, well, clearly this model would fit, but we know that this is a really hard thing to do. When we were doing this a few years ago, there was always a problem whenever you tried to commit your code, it broke someone else's change, and it just became so painful that we stopped doing this and decided there has to be a better way. I think the tools have improved, and this is something I'll come back to in a few slides. But I think the pain when we were trying to do this meant that we've decided there's a better way. Let's work on some more isolated branches so that I can do my code and you can do your code, and we're not going to break each other until we check in. And then there's a problem. The second person has to fix the code to make it work with the first person. But, oh, here comes a hotfix. And now we need to do some more refactoring and rework, and now we've got to merge all of that stuff together. Let's branch it off into a release, and another hotfix, so we've got to do some more merging in here. And meanwhile, another developer has already started on version 4.6, and he's got to merge his code in, and I feel really sorry for the person who's already started on another feature, because they're going to have merge hell. Has anyone seen, is this pattern familiar? Has anyone seen this sort of a pattern before? Almost a lot of nods around the room. Now, I know people who work in a team whose job it is to do the merge hell at the end. A whole team of developers whose daily job is to fix the problems from all the other developers whose code doesn't merge. I kid you not, there's a team just doing code merge. That's all they do. Right. Right. Is that a waste? Is that effective? Is that efficient use of their time? No. So clearly this has some huge challenges in doing anything close to continuous integration. I know I've had some challenges and some conversations with people. Well, but we build it daily. But well, if not an isolated feature, you could be pulling in your code, so you're always getting the patches and hot fixes, but you're only getting in whatever is already in master. You're not really integrating what's on this feature line and what's on the other feature line above it. You're not integrating those two unless they're checking in and checking back out, or committing, pulling, and pushing. If all they're doing is pulling up whatever is in the development stream, it's better than not doing it at all and waiting until the very last day before you merge everything together. But it certainly is not continuous integration if these two branches, these two features, have never been tested together until here. Okay. Has anyone tried or experienced trying to implement continuous integration in a pattern like that?
Have grey hair.
You have grey hair. Not working.
I got it.
Gave up.
Yeah, well, once upon a time there were no DPCSs, so you didn't have so many choices. You had
Great. Anyone else?
I work at a company that still does this.
Me too. In some teams.
Their entire creativeness of that team was literally tied up with just fixing things.
They're painful. Very painful.
It's a waste of talent.
Right. How are you going about changing that?
Oh, I'm not there anymore.
Oh, right, there we go.
I'm
Right.
happy about that, and I think they're still doing okay, although they were caught up recently in that whole ransomware stuff, so they kind of have been that.
All right, say no more.
Yeah.
All right. Okay, so this is definitely a challenging pattern to improve as long as that code is, well, it kind of says it in the title at the top there. If they're on an isolated branch, clearly they're not integrated. Right? And if they were continuously checking in and committing and pulling and pushing, why bother having feature branches then? The purpose of having the feature branches is to keep them isolated, so I can deploy that out and wait until it's all done, fully finished, and make sure that I don't get my thing which is partially finished into that 4.5 development until it's really all complete and finished. So there are challenges in doing this, and I think we've now started to mature and get some better ideas about how to do continuous integration, even when we want to start work on some other features that aren't going live for a few weeks, certainly not to the customer. Okay. Short-lived branch development. We have short branches, maybe just now 1 or 2 days. So this is certainly way better than that last slide. Has anyone experience in a team trying to do short branches? A few hands. Maybe a little bit sometimes, maybe.
They're not that quite that short. They're short, but not that short.
They're not short, not short. Okay, cool. Look, this could be this journey, right? If we go from those feature branches which are out for weeks, and we now have a branch that lasts a sprint for 2 weeks, a 2-week branch, that's better than we were. Still nowhere near getting continuous integration, and if we're not continuously integrating, particularly with other teams, and we've got dependencies on product X and product Y, components merging together. But this is certainly getting closer, much closer. I've seen some presentations from teams who were trying this and found, well, this is still nice again in theory, and we can draw it up and we can say, oh yeah, we'll do this. And then in practice, it just doesn't work, because our development always takes longer than we thought. And what we thought was going to take 1 or 2 days takes 3 or 4, usually 5. And then even though this is nice in theory, we still end up with branches that aren't short enough, even though we try and get them to this ideal. So it's certainly maybe plausible that we can do continuous integration on here if we can keep them short and keep them merging at least once a day, if we can get it down to 1 day. But it does mean that I get a little bit of leeway if I'm working on a task, it doesn't break someone else's work. I can still get a little bit of separation to make sure that I'm not going to commit partially complete work that screws someone else up. I'm going to wait until I'm happy that that piece of work's done before I commit and make sure it integrates with everyone else's work. So that certainly is a pattern that is definitely better. But I think we've seen there's still sometimes we'll get some issues, but not as many as we had when we were doing it continuously. But the trunk-based development, I think we've got a lot more patterns and practices in place now that this really isn't as painful as it used to be. We've now got a lot better code quality tools that are checking our quality code before we commit, and we run a lot more unit tests before we commit. I had last week, first time ever, I've heard developers want to run acceptance tests before they commit their code. Unheard of. Unheard of. But I spent the first sprint, this is the team in sprint number 4. Never done agile software delivery before. In sprint number 1, I trained a manual tester how to write some automated tests, some acceptance tests. I set up the pipeline in sprints 2 and 3 so that when we build, it triggered a deployment to an environment and it ran those tests. Sprint 4, I had developers who told me they want to run those acceptance tests in their local environment before they commit. It's completely unheard of. But I'm happy that there's such big change in the way that we're thinking. If I told them to do it, no, I'm not doing that. Testers can deal with that stuff. I need to write my code. But the change in thinking has been fantastic. That they want to run these tests and make sure it integrates successfully, because they know if they don't, it's going to show up on a board, broken the build.
That's not surprising.
Absolutely.
Because no developer wants to release defective code. The fact that
I know this is a room full of smart guys. You already know this pattern.
I mean, it's what is surprising that it's it's not more widely done. That we've got acceptance tests that have an emphasis placed.
Right. This has been a big change for me in finding a new spot in my career from testing to DevOps. My role is now helping to set this process up and help uplift that capability. If it wasn't for me, they'd still be doing manual testing, and we haven't got the capability that we can run these acceptance tests straight up. Now, as soon as a build commit is triggered, it will automatically deploy and automatically run them. And that would potentially still have been a lag or a delay of an hour, 2 hours. Can you go and run those tests again for me and check it works? As soon as you commit, they run and they come back in 5 minutes, it's done. So it has been the need to change the process to help drive that change of thinking.
How do you quantify that need to think about really paying for the upfront cost of doing it when you don't have to?
Right. I have had exactly the same sort of patterns. I had a couple of IBL placements come in, some developers come in and join my team with the intent of creating some automated tests. So they had developer experience. They spent 6-9 months doing manual testing. I just couldn't get beyond the need to do manual testing. We don't have time for that. You have to do manual testing. You don't have time to automate the tests so that you can run them. Yeah. So
what's the argument? What's the powerful argument for doing that? Or can you not? If that's the mindset of the people that make those decisions, is there no argument that you can really?
But you need the courage to have that argument, and if you can't, then you need the courage to change job. Sounds like you did that. It's absolutely. If there's so much you can do to surface and try and implement change. Sometimes you need the courage to push the change. It's hard to be a leader without the followers to back you up and say, this is right. That's why I know that we still have this contention on what does continuous integration really mean, and everyone seems to still have a very different idea about what that means, and are we doing it? Oh, yes, we are, because I've ticked the tick box. It's hard, and it's not easy to get agreement and support. Question?
Yeah, I just sort of got a comment on that. It sort of feels to me it's all about experiment. We're spending this long on manual testing. It's the same testing all the time. I think if we automate this, it would be quicker.
I like the idea you try an experiment. All right, can we just get agreement? Can we just spend? Can I block out half a day in a 2-week sprint? Can we spend half a day just trying to get one test? And you just see that login test or that that thing that hits the API. Can you just try automating that one? And just try and see if it helps. So I ran some dev school sessions and I trained some of my manual testers to write automated tests. And that seems to be my new pattern that I'm trying to encourage. I mean, the testers love it. They want to write code. They know their career path as a manual tester is on a slow decline and have known it for a long time, but they know we'll stick a head in sand and denied. They're keen to learn code. They want to automate tests, but they're not given time. They're under pressure to just get the features tested. All right. So maybe there's some patterns if we slow down as a team and understand the big picture. Can we slow down some development a bit and give them a bit of breathing space so that they can? Let's go through an architecture re-platform that gives them some time to breathe and no, they're allocated to another project now. I do want to move on through some other slides and hopefully we'll answer some other questions about how do we go back to continuous integration and have to answer some other questions at the end. Back to our continuous integration theater, because we're all doing continuous integration, but we're not doing this stuff. What are the things that we can do and what questions do we need to ask? How can we do that? That is tricky. We've got the questions coming up. There we go. So these are some of the common questions that I've had. So how can we possibly do this? How do we do code reviews if we commit multiple times a day? I'm spending all of my time in a code review, not writing any code. Any ideas, suggestions about how we can solve some of these issues? Yes?
How do you calculate
Pairing, pair programming. Excellent. That's right. Love it.
You review the for attack of the story and not with every comment.
Yeah. Certainly if you're doing it, I'm changing the font from blue to red, or you might think, I don't need code review of everything. Yeah. You can have some things. I only do the code reviews where it's necessary, where look, I'm making a big change to this component. I really don't know the system well enough to know if there's something else that's going to break. I really appreciate a code review on this thing, but otherwise let's just pair program or not do it for every minor change. But that's often a challenge to hear, well, how can we do this if we have to, who's doing the code reviews? How do we deal with dependency conflict? Right, dependencies between components. I can't check my stuff in because it's going to break until someone else checks their stuff in. Feature flags, feature toggles, excellent. Yeah.
There's one extra. If we take the dependency and make it into a technical feature, it's right.
Sorry, Mike, I've got a separate question, sort of on that feature flag. So we're doing continuous delivery. We're trying to solve the question of one release train versus 2 release trains. So I just want to get your thoughts on the feature flagging and how that can work in a sort of more practical construct.
I've seen teams use some other role-based permissions and have some other controls. It's not just still a feature, it's on or it's off, but there's some of the context that goes with that. So it's only on if you're an internal user or if you're in a particular customer segment. We'll isolate and only allow certain users with that feature flag. So it's not just still it's on or off. We can still control out a soft release of that feature out to different segments of our market. Maybe it'll only be on for New Zealand. Yeah, so we'll look. There's different patterns around how you create those feature toggles. Whether that's in a user directory with permissions, and you can then toggle on permissions at that level, or whether it's on for a region, or it's on through just the load balancing the URL that you hit. If you're in the know, you know to put a question mark version equals 4.6, so you change your API headers, and if some of that traffic goes to the new version, some to the old version. Different ways you can do that pattern, but we want to move away from doing it in code or branching in code and do branching by abstraction through some toggles at some level. And it may depend upon whether we're looking at the API level, are we looking at the product? This is a big change and you've got components and 2 systems that need to talk together. We need some agreement about what the version numbers is and how we can isolate those changes together. Yeah, I don't know there's an easy one answer for that.
But the view of running 2 release trains of different versions of code, what are your thoughts on that?
I'd say John.
Yeah. How about we have a conversation at the bar afterwards? I think that's more than 2 beers worth of talk there. All right. Backwards compatible changes. How do we deal with changes and make them backwards compatible? Because I'm going to keep on releasing.
You need confidence, which means you need a high level of automation, but also needs to be quick.
Yes. Yep. So there could be, I mean, there's different ways we can version out our APIs. Some of them I know you will do it through a URL, do a query string, and there's a, I'll leave that argument as to what the right way is because everyone's got a different opinion about that. But it is possible to make changes and not to break anyone. And at a certain time in the future, when you want to make that live, you now can change the requests coming in and use the new feature, and it'll funnel it off. We no longer have to have changes that are or be scared about breaking the build or breaking the changes because we've got tests that are forking off onto the 2 different paths and making sure that they still work. Database is a tough one though. How do we do database changes?
Automated data migration.
Data migrations?
Expand and contract.
What?
So if you've got a change to a particular column, if you're talking about schema change.
Yes. Yeah.
Contract, so you remove the old column.
Excellent. That's absolutely. So we couldn't do that when we used to have patterns of releasing once every 6 months. You had to do this big data change and had to do all this migration of data and it had to work. And it's, oh, how's it going to work in production? You have no idea, big bang, big problems. But if you get into a continuous cycle where you're able to release even once a month, I can add another column to the database. Next month, I'll migrate some data, test it works, even though the feature is still switched off. I'll just test the data migration. After 3 months, I'm happy, delete the old column. And you can still do continuously forward patching, forward changes. So, yeah.
The lovely thing about having code to do that is that in conversion, you can roll it back.
Yes. Yes, you're just now getting your code to look at the new column in the new field rather than the old column which just had the booleans and allowed nulls, right? New column, no nulls allowed, right? So yeah, you can do that. These are all possible. These are all things that we can do to improve our ability to check in multiple times a day and not break the build and not have these challenges. But they are hard. It does need us sometimes to change our architecture pattern. Maybe we need to look at some architecture, some ways of making them more modular and microservices as they've been around for a while now. But there's all ways we can change. Not always possible with legacy code, but there's certainly still some things we can do that make it easier to deploy to the same master multiple times a day. Let's go through a couple of other quick slides. Testing. Any ideas? What's an acceptable code coverage level? 100%. Really?
It's the only acceptable code coverage level. If you, Uncle Bob Martin's talk at Yale, he said that if you say that there's 5% of our code can be defective, what is that? As a like it's just whether or not that's like the reality of the world. That's a different question. But in terms of what's actually acceptable as developers.
I'd certainly love this conversation that it starts and it's suddenly
I also say it's the only true measure of code quality is what costs per minute. Acceptable code coverage is subjective term based on knowledge of the domain of the code itself.
That's right. I've run some unit tests, 100% code coverage. Didn't test a fucking thing other than it allowed nulls, right? I can pass in some email addresses with garbage and it goes through because my unit test only did one pass if it allows nulls. So I can get code coverage. It's a loose metric, but it's really not measuring the business logic, it's the code working. So, hey, look, I think it's a great conversation to have with your teams. Now, 100% code coverage is not the goal. It's reducing the risk. There have to be good tests. And really you want to get maybe a tester into your team and talk to them about what tests they run as acceptance tests. I'm going to run it as my unit test because I can test this in milliseconds. For you to do the login tests and actually go to the My Profile screen to test an email validation, it takes you 30 seconds per test scenario. It takes me 3 milliseconds. Okay? Give me all of your email addresses that you're going to validate. I'll plug them into my thing. You'll know that code works. All you're doing is just adding delay, right? Waiting for it to deploy, waiting for it to run. It's taking 15 minutes. I ran it in 15 milliseconds. Yeah, have a conversation with a tester. They're really good at finding, the scenarios to plug into your tests. No knowledge of the code, you don't need it. I just need to know what scenarios would you do, and I'll plug them into my unit tests to make sure my code works.
Works really
Pairing. So it's not just pairing with a developer, pairing with a tester as well.
Yeah, and whilst they're writing unit tests as well. So you.
What company do you work for?
Regentis. We're we do DevOps stuff. So
Fantastic.
This is my bag.
Excellent.
I can't remember who said, but someone saying that the role of a tester is not to write tests or do testing, it's to design tests.
Absolutely. Yeah. Yeah. It's one of the hardest bridges to bind is to get testers with the knowledge about how to break something into your team to help write the test, design the test that can run much faster. So I put in here a question about what are the levels and types of testing. Do you do security testing, performance testing? We've got a number of other tools now that will really help us get the quality and help us not break the build. When the build or test fails, the whole team must stop immediately and fix it, says Jez Humble. That's tough. Why should I care? Someone else will fix it later. I'll let it go red and I'll walk home. Well, you do need to get this to be safe. If you have a red light on the board and it goes red and it's a scare, no one wants to check in the code and make that light go red. I've seen teams start to go backwards. I don't know, has anyone else seen this pattern? I'm now scared to check in the code because everyone's going to see it's going to be my name against it. Even depending upon your level of how visible it is, I still don't want my name against the build that checks in. And I have seen the positive side where developers have changed their behavior. I want to run those acceptance tests locally on localhost before I check in to make sure it's all passing. But it can also have a negative effect depending upon the environment that you're in. If it's not safe, I'm not going to check in and be the person that's going to break the build. I'm going to keep it on a long running branch. I'm just going to check in once. If it goes red, at least it only went red once. Right? So careful as any, no, we need to have this right environment and we need the right conversations. It's perfectly okay to break the build. It is not okay if it stays broken. There's a difference. I do not want a red, maybe I'll change my patterns. I want that build to go yellow. If you break the build, it's fine, it's just gone yellow. Maybe it'll be a slight yellowy greeny color, right? If it's not fixed within an hour, now it's going to go red. Is that going to change behavior? Maybe change your thinking a little bit? It has to be safe to break the build. It's perfectly fine. We all make mistakes. Breaking the build is fine. Leaving it broken, that's the sin.
Would you also say then that if it goes yellow or red or whatever, that you don't assign blame, you don't assign a name to that thing, and you have the whole team sees the team's build has gone red and the team needs to fix it? Is it just about not assigning, make it easy to assign blame?
If there's a challenge about assigning blame, we have some other trust issues in the team, and we've got some other concerns, not just about the code, but about the working environment that we're not. No, pair programming may be a real challenge in those kinds of teams. That it's one person always steering the conversation. Or, well, he did the code, and no. Yeah, we've got some other challenges if there's other trust issues here. Why is it so important that the whole team stop though? Why not? Oh, that person broke the code.
The whole team's product.
Yeah, cool. What happens if I leave it broken? Well, it means that I can't really check in my code and make sure my code works because I'm checking in potentially broken code on top of broken code. That's why this is important. That's why that rule is there. Why 10 minutes? 15 minutes? Or can I do it in half an hour? Well, the longer you leave it, the more problems you have that I can't make sure my code works because it's already broken. So that's why this has come in. Make sense? Okay, so we've spoken about this. Let's head into a summary. What happened to our beanstalk? About branches. It is hard. Really trunk-based is the only one. Now maybe I gave it away in the title of this talk. We have to chop off all of those branches and just chop down that beanstalk. The only real pattern of getting continuous integration is really trunk-based development, but that is hard, and it is a challenge in getting to that level.
On that, do you have any opinion about Git flow versus GitHub flow?
No. I shall leave that another time, I think. We'll ask a friend in the corner. Okay. I think continuous integration, it is hard, and it's not just about this branching strategy. Right? It's clearly we want to chop them off and to get rid of those branches that keep code in isolation. But there's a number of other patterns that we have to change first. And there's architecture patterns. There's the new tools that can automatically check the quality of our code. We can now do security tests, performance tests, making sure we're using tabs or spaces. No one uses them. Right. It is. See? And let's.
There was a study that I can't remember if it's
Stack Overflow. It's in the latest
Oh, yeah,
Stack
yeah,
Overflow
yeah,
server.
Database changes can be done. We can make backwards compatible changes. We can change the way we build, change the way we architect our systems. Really need some more conversations with your team and with your architects, and maybe if you're working on dependencies with those other teams, how can we together, can we have like an hour, just catch up and explore this once a week? Let's have a catch up once a week and see if we can nut something out and make some changes in the way that we build stuff. It is hard when you've got a large organization with dependencies on stuff that you don't even know, and you've got to reverse engineer something. So there are certainly a number of things that together, maybe two of them, if you can do two out of all of this stuff, it will certainly help us to get on the path of being able to do CI and actually get out of this theater.
Why is CI easier with NoSQL than normal C?
Potentially falls into pattern of there's less relationships or tightly coupled relationships between the data. So if it's NoSQL, it's easier to rolling updates and add new fields or add new data into that document or MongoDB. Continuous integration is just part of this big picture though. If there's continuous delivery, deployment, feedback, and learning, continuous integration is really, really hard. But the good news, really good news, continuous deployment, that's easy. That's just a checkbox, and I'm doing this here. Hey, so you've been a great audience, and thank you for your participation. And Mike Jones hasn't learned anything from continuous deployment. So these are the two books. I'd highly recommend you look at the one on the right-hand side. It's really detailed. It's got huge chapters on continuous integration, huge chapters on how to do testing, what kinds of unit tests, how to do acceptance tests. It's $30 if you buy the ebook version. It will pay you back magnitudes in the dollars you can put on your career. If you can actually implement these processes in your development, you'll be able to work anywhere in the world. So I'd highly recommend that book. Give that a read. Now I'm happy to take any questions. If there are any in the room?
What would you say on competing ideas of checking to a trunk line, the build potentially fails and then you fix it within some time frame, versus you go to checking code and code can't get checked in unless it passes? So I think at Google uses a similar model where you put a change up to be committed, and if it passes, it will be the next change.
Right.
And then that continues, and so it never goes red.
It never goes red. That's I think a great pattern or way. Well, so certainly is a way to force that change of behavior. That teams, you have to run all those tests. They'll run automatically for you before code gets committed. Maybe for some small changes. I just made a change from that color is going from blue to red, and I have to wait now 10 minutes for this thing before I can get my code into the commit. Maybe it's the change of behavior can over time mean I don't need that because I've run it, now I can run them locally. This change is so small, we've done some pair programming. And if I have to run a 10-minute build every time I do a commit, that's going to slow me down, and I'm spending an hour and a half every day now waiting for my commits to run before I can move on to the next thing. Maybe there's a balance here. I don't think
it's so much when you commit, you still commit locally. It's when you want those changes.
So when you want to push in.
Every few hours or every day, then it doesn't go in unless it's green.
I think it's, yeah.
On a merge.
I think there's. I think you get a different answer from from many different people on that. And I think if it works, try it out and experiment. If it's helpful, if you're getting faster throughput, keep doing it. If not, change it. But no, oftentimes I want to try out different ways of pair programming with teams. So I know mob programming. Let's get a developer and a tester maybe a mob programming. Yeah. Yeah, so I attended a mob programming session at LastConf last year. Yeah, it's excellent. I wrote some code. But we had 5 people around one keyboard, and it was really a really fun experience to. Yeah. Right. So it may not be useful on everything, but it may be where there is something which is high risk. You want to have more people involved. Let's nut this feature out. Can we have 5 people around one keyboard? This other stuff, that's just changing the font color. Go nuts, go crazy by yourself. But where there's a complicated one, let's try out. It's going to be much more efficient if we can have people all together to work this as we.
Especially refactoring. I like mob refactoring, mob programming question, mob refactoring. Because
Mob refactoring.
No one wants to refactor
Yeah.
that broke the code based on refactoring.
Yeah,
That's why you get
we're going to do
code rot, right? And the courage and whatnot that you get from having everyone in the room is really good with that. And so that adds into that whole thing around like if you need to refactor to write automated testing as well, because that's often the reason why you have to refactor, because you're like that code is not testable on an automated basis.
So you'll have to have the testers in, because if I change my code, it's going to break your tests.
Exactly.
Yep.
So you get that, like it forces you to think about like the whole cycle, like software cycle. So that cycle time can be reduced.
But the test thing, you also have to think about the flow of the tests from CI through the feature integration testing, system integration testing with a latitude, where in production environments, testers have to get familiar with form automation for most of the good.
And you've got to change the whole discussion as well. From devs do development and unit testing, and testers do functional testing. That's a bit of bullshit, because they're doing the same thing in places that result turn into a shared discussion about what do we need to test, where do we test it, how do we do it most effectively.
So I have one last little small question.
All right.
Anyone in the room got familiarity with QuickCheck or any of the tools that derive from QuickCheck? It's a Haskell thing. If you haven't, go Google it. I don't know if you've played with QuickCheck at all.
No.
Worth it.
Okay, quick check.
A little bit more so. There's a lot to say about it. Not long ago.
Right. Okay, thanks everyone. Hopefully we all know a little bit more about CI, and hopefully we'll have less arguments about what CI really is and can focus on how do we get there. Thank you.
Can I just do a quick ask? Who's done mob programming? Cool. If you're interested, I'd like to have just a quick chat about how you do mob programming.
At the Game Without Drones Lego session, we'll be doing mob refactoring Lego. So if you want to come along, free fill.
Thanks a lot, Mike. I enjoyed that session.
Cool. Thank
See
you
you around.
See
Thank
you.
you.